Hey everybody, welcome to a hybrid version of the Python Pirates meetup. I'm Chris Thompson, your captain, and today we have Adam Yala. Yala. Okay, just making sure I'm pronouncing that right. Adam Yala, who's going to be telling us about HTTP and Python, making HTTP requests online, which is a super oft overlooked topic. And can be important for everything from making requests for machine learning models, making requests to online APIs, web scraping, all kinds of stuff, and even on into security applications. So if you're doing pen testing or anything like that, which Python is really popular for that. So without further ado, I'll hand it over to Adam and we'll get started.
All right, thank you, Chris. So before we get started, I just want to send a big thank you to the Portland Python Pirates for organizing and for Tech Academy for giving us some space to meet in person. So let's get into it. Welcome to HTTP and Python. Before we get into the content, I wanted to introduce myself. My name is Adam. I work as the Chief Technology Officer at MetaMe Health. We make healthcare software. And that software makes many HTTP requests and accepts many HTTP requests. In part of this talk, I will show some of how we do that. I'm mostly self-taught, but I did minor in computer science in college. Formal institutional computer science classes are kind of useful. They teach a lot of abstract concepts, but they don't really teach a lot of how to build stuff. I've also been coding for almost 10 years, and most of that has been web. I've spent almost all my time in the web space, and as a result, in my mind, I believe that Python is mostly web, but in reality, it's really just a very small corner of the Python world. And lastly, I use Python because of the community. Countless Python programmers have taught me how to write Python over the years for free, and I consider it a responsibility of mine to pay it forward. So an agenda. We're going to go over the why, what, and how of HTTP requests. Then we're going to talk about making HTTP requests, and towards the end of our talk, briefly talk about serving them because it's kind of a complex topic. We'll also be going over what I consider real scenarios. So I'll be showing you code from the code we use at work and from some side projects. My hope is that everyone listening to this talk, regardless of your skill level, can take something away from the talk. So I hope to start really simple and then just gradually get more complex as we go. So first up, why HTTP requests? I personally consider an understanding of HTTP to be a part of internet literacy. So let's say a small local business has a website and at midnight, they release some merchandise or tickets to an event, and you go to the website and it's getting hammered and it says 500 internal server error. I think part of understanding how to use the internet should be knowing what that means. HTTP requests are also everywhere. They're in your browser. When you type in a web address and you hit enter, you're making a request to that site. They're in your mobile apps. When you open up your Uber app, the app is sending your location to the Uber servers, and it's sending nearby drivers back to your phone. And also these days, even appliances make requests. If you, for some reason, have an Alexa-enabled microwave and you decide to attach it to the Wi-Fi, it makes network requests, HTTP requests to Amazon servers. And more than anything, it's been heavily used at every single software shop I have ever worked at. So I feel it's an important thing to discuss. Can we move this out of the way? Yeah. Cool. So Python and HTTP use cases we'll cover. We're going to talk about web scraping. To me, web scraping is typically used to get a data set that is not readily available. If a source offers a data set through an API or just a file download, you should absolutely use that because web scraping is kind of a pain, but it is a great use case. We're going to talk about working with a JSON API, which in my opinion is most of modern web development. It's making and accepting HTTP requests and accepting and responding with JSON. And then we'll also briefly talk about serving HTTP requests. So what is HTTP? It stands for Hypertext Transfer Protocol. And in this context, hypertext refers to the hypertext markup language, also known as HTML. A protocol is a standardized way of doing things, and that means it is a way that we've all agreed that we should do something. So that means that HTTP is a way of sending HTML around the internet that we all agree on. Since then, the protocol has evolved, and now we send everything over HTTP. HTML, JSON, CSV, images, music, you name it, and it's being transferred. And I think the real thing to remember is that protocols are very important. So if we think of units of measurement as a type of protocol, it would be a real shame if you ordered a pizza and ordered an 18-inch pizza, but the pizza shop gave you an 18-centimeter pizza. So there's like a little mismatch with the protocols that you're using. And because of that, people become unhappy, and there's a miscommunication. So most HTTP requests start off with a URL or an IP address. In this case, we'll focus mostly on URLs. If we break this down, the HTTPS at the front stands for, we've talked about HTTP. The S stands for secure. And example.com is the address the information is located at. Another protocol that many of you might have seen is FTP, the file transfer protocol. So if you've ever used FileZilla to move files around the internet, or used it with WordPress, then you've used this protocol in the past. So let's make an HTTP request. This is the Firefox web browser, and everything I'm about to show you can be seen in Firefox, Chrome, or any modern web browser you use. We typed example.com in the address bar and then hit enter. And at the bottom of the screen, we have the browser dev tools. And these days, web dev tools are just shipped with every modern browser. When you type in an address and hit enter, we send the request. And if we go to the network section of the DevTools, we can see the requests that the browser is making. In the bottom right corner, you can see that we got a status OK 200. So things went through well. If we blow up that little bottom right corner, you can see more information about the request and the response. So we can see that both the response and the request both had headers, and the response had a body that it sent back. And that body was HTML that the browser received and then rendered into a web page. And it's important to remember that the rendering of the HTML is not part of the HTTP protocol. That's something the browser does. HTTP focuses mostly on the communication going back and forth. This diagram is a great example of the typical HTTP request and response cycle that we all see day to day. So on the left here, you've got some phones and desktops and browsers making requests to a server, and that server is sending back information. That server can be running any language as long as that language implements some way to use the HTTP protocol. In terms of this talk, this new diagram more accurately represents what we're going to be talking about. On the left, we've replaced the laptops and phones with a server that is running Python. Python can run in the browser, but these days it's usually run on a server. The examples that are featured in this talk are designed to be run on a server. Yes, the Python runs on your laptop while you're doing your development, but in its end state, it's intended to be run on a server most of the time. However, even when looking at this cycle, it's still sometimes difficult to understand HTTP requests. And I feel that it helps a lot to compare it to a real life process. So let's say that you're calling up a bureaucratic agency and you're saying, hello, agency, please process and send me the document I need. And then they send you back this document that we have here. In grade school, we all learned that the top part of a document is the header of the document, and the bottom part is the body or the content, and that the header contains information describing the information in the document. In this document, we can see that the date it was issued at was July 27th. It's from the example agency, and it's valid until a certain date, and that's because it was approved. So the agency approved it and said it's only good until this date, and they have very specific instructions on how they want us to respond. They want us to respond via fax. If we took the information from this screen and overlaid it on to our document, it would look kind of like this. We would be making a GET request to example.com, and it returns a response that contains the date. It contains who it's from, when it expires, the format they would like us to communicate back in, a status OK showing us that this was sent correctly, and the HTML we requested. So to review the anatomy of an HTML request and an HTTP request and an HTTP response, there are headers, and that's information about the content. There's content, and then there's a status code, which is a 3-digit number that represents the successfulness of our request. That meme in the upper right corner is a somewhat famous internet HTTP code cheat sheet that describes different status code categories. The 3 at the bottom of the screen are probably the 3 you will see most often. 200 OK, everything's good. 404 not found. And then this is the one I mentioned earlier at the bottom, the the 500 internal server error, meaning that whatever you're trying to communicate with hit a fatal error and just could not return. So let's make a request in Python. Python comes with a myriad of wonderful built-in tooling. The one we want specifically is a function or a method called URL open. In this example, we're giving URL open the URL that we want to make a request to. It's giving us a response object, and if we run .read, we get the content of the response. So this would be the HTML of the page. It also comes with a couple other functions. So we have get code, which gives us the status code, and get headers, which gives us a list of tuples of all the header information. It's not the ideal format we want, but it works. It gets the job done. And before we go further into Python, I wanted to compare making an HTTP request in Python with making an HTTP request in JavaScript. I feel that most web developers and programmers these days kind of start out with JavaScript, so it might be a good frame of reference. It's important to understand that these requests that are being made are the same exact request. And the reason this is possible is because the HTML protocol can be implemented in different languages, because we all agreed on a way to do something. And if a programming language is a way to express logic, we should be able to express the same logic in 2 different languages. To me, if we go back to our earlier example of hello agency, send me the document, one of these would be like asking the agency for the document in English, and the other would be like asking for it in Spanish. You can call up the Spanish embassy and ask for a document in English, or call up the British embassy and ask for a document in Spanish, and your success may vary because the protocol is not matched up. So even though you're asking for the same thing, there are different ways to express it. Another thing that I wanted to touch on is JSON. So what is JSON? JSON stands for JavaScript Object Notation. If you remember those dev tools I showed earlier, they contain a console where you can kind of play with JavaScript. So I created a demo JavaScript object here for us to look at. It's a dog object, and it contains a breed and age and colors. And what JSON is in HTML to an extent is these are often referred to as structured data. And structured data means that information or data is set up in a predictable, documentable, and explainable way. So anyone using my dog object, I should be able to tell, if you go to the breed key of the dog object, you will get the breed. And as long as we remain consistent, we can use this to communicate information. In Python, JSON feels a lot like a dictionary or a list of dictionaries. It can be accessed as so. These days in the modern web world, web APIs will usually return JSON. Back in the day, they would return things like XML, but that's less common these days. So to start out with looking at JSON web APIs, we're going to look at the 7-timer weather API. This homepage doesn't look like much, but it's a great weather API. And a reason why I recommend people learn using this API is because it's free and it requires no authorization. So you don't have to log into anything. You don't need an API key. You just grab a URL and go. So let's look at what a URL requesting data from the 7-timer API might look like. At the top, we have the URL for the API. And after this question mark, sort of in the middle here, we've got a bunch of values after. And these are called URL parameters. A place where you might have seen URL parameters in the past is if you grab a link from social media or from an Amazon shopping store or another big website, you'll see something like in this bottom right red text where there's a UTM equals some string. And this is used so that when the URL is accessed, the website understands where the traffic came from. It's a means of tracking. And while that's being used for tracking, we're using it as a way to specify what kind of information we want. So to quickly explain the parameters we're passing through to the API, we're giving it a lat long, which is the lat long of Portland. We're asking for our temperatures in British imperials. That way we'll get Fahrenheit, and we want the output in JSON because the API is designed to give lots of things, but we'd like it in JSON. If we take this URL and we copy and paste it into a browser, it will return JSON, and the JSON just gets displayed on the screen. And while this works, it is not very useful because we can't do anything with this JSON. And this is one of the use cases for making a request to an API in a programming language. It's that you can get the output back and perform logic on it. So let's put this URL in URL open and get the content back. So at the top, again, we're importing URL open. We're storing the URL, we're giving the URL to URL open on line 3, and then we're using .read to grab the content of the response. As I mentioned, Python has a ton of wonderful tools. One of them is a JSON parser. And if we take that response content and give it to the .loads method in the JSON module, we get a dictionary that we can then manipulate in Python. So if we wanted to, we could access the init key in the content, and it'll show that I made this request on August 18th at noon. And then we can loop over the data points it gives us back and look at what the temperatures would be a certain number of hours from the time we requested them. So you can see that, like today on the 18th, it was pretty hot. 12 hours, so around, I guess that would be around midnight. It was still pretty darn hot. Luckily, there is a better way to make these requests, and that is using the requests module. This is a third-party module. That means it does not ship with core Python. For those who may be familiar with Python, this means you have to pip install the module to get it from the internet. So why do things like the request module exist? I would say there are two big reasons. One is for convenience. There are lots of things we'll do, like import the JSON module and then run JSON.loads. And instead of doing that every time, requests can help do that for us. Another big reason why requests is a third-party library is for security. I believe Python releases a new version or a minor version every 9 to 12 months, which is kind of a long lead time. And the Python versions they release affect enormous numbers of people. Whereas requests, even though it has 50,000 stars on GitHub, it's still a smaller number of individuals than Python core affects. And they can also release new security updates whenever they want. So it's very advantageous to decouple some of these libraries from core Python. So what does it look like when we use this to fetch some HTML? Cool. So on the first line, we're importing requests. On the second line, we're running a GET request to example.com. And on the third, fourth, and fifth line, we're accessing the same anatomy parts that we looked at earlier. So we can get the status code, we can get the headers, except it's much better now because it's a dictionary. So it's going to be easier to access the information in those headers. And then the response.text contains the HTML of the web page. If we were to use requests to query the 7-timer API, two big things change. The first thing to change is our URL parameters are no longer a long string that's just tacked on to the end of the URL. Now it's a dictionary. And when we pass this dictionary to the get method, it will URL encode it for us and just add it to the end of that URL. And the big advantage of this is, say we wanted to reuse some of this code, we could set it up so that the lat and long are variables that we pass in, and then we can query the weather in any location we want. The second big change is this response object now has a .json method. So instead of importing JSON, we can just call .json and have it parsed and encoded for us. So the rest of this talk focuses a lot on requests to JSON APIs. So I'd like to go back to web scraping for a moment. To recap, we can fetch HTML using requests using the .get method. And I'd like to give a use case of web scraping. So I play a video game called Dota. And Dota is, if I were to describe it, it's kind of like League of Legends, for those who have played it. For those that are unfamiliar with either, these games are kind of like a 5-on-5 pickup basketball game, but with wizards and fireballs. In this game, in both games, you can get items for your character, and those items have different attributes and stats on them. And I wanted to build a tool that would allow me to compare stats on different items. But unfortunately, no data set of these items exists. So this is a perfect solution for web scraping. To scrape these HTML pages, we're going to use another third-party module called Beautiful Soup. So we've talked about structured data. And what Beautiful Soup does is it takes structured data like HTML and XML and makes it queryable. So what that means is we can pass Beautiful Soup an entire page of HTML and then ask it for things like, give me all the text on the page, or give me all the text on all the buttons on the page. And we could do this using just regular old Python, but it becomes very cumbersome. And as you'll see, even using Beautiful Soup, web scraping is still cumbersome, but using this makes it much, much easier. So where will we get this data from? There is a website called Dota Buff that contains information about different items in the game. And if you can see in the bottom left corner, this is a screenshot of me mousing over this magic wand. There is another URL specifically for the magic wand. And if we click on that, it takes us to this HTML on the right. And it has a lot of information on it. But the part I want you to remember is this plus the read to all attributes. So what's our plan to scrape Dota item data? It's going to be to go to that items page, get all the links to all the items. Then we're going to send an HTTP request to every single link on that, load that HTML, and then parse that out to get the data we need. So let's run through some of this code. In this code, at the very top, we're importing requests. Then we're importing Beautiful Soup. We are then making an HTTP request to the items page. We're getting that HTML and giving it to Beautiful Soup. And then Beautiful Soup is giving us that structured queryable HTML. And in the upper right corner, I put the snippet of HTML that we're trying to parse. So I've asked Beautiful Soup to find all HTML elements that have the class cell extra large, which you can see right there on the TD. Then we initialize a list to hold the item links in, and we loop through all the cell extra larges on the page, and we grab their A tags and then we grab the href value from the A tag and we append it to item links. So when this code finishes, the item links list becomes a list of all the item links that we need. To finish this up, we're going to loop over that list, and in the upper right corner, I have the HTML from that +3 all attributes. We're going to make a request to the item link, grab that HTML, go through the same process of giving it to Beautiful Soup, and then the rest of the code targets individual CSS classes in the HTML and pulls data we need out of it. And by the end of the script running, we can end up with a JSON object that looks kind of like this, or a dictionary that looks kind of like this. The code I showed you was simply to grab this bottom stats object. So the rest of this, all this other information requires its own custom web scraping code, which I hope kind of illustrates how cumbersome web scraping is. And the really beautiful thing about this is using this data that we scraped, I'm able to build a little tool to browse Dota stuff. So this is a little web app I made that lets me pick different item attributes and then shows them along with some statistics that I wanted to see. And this would be impossible to make without web scraping, and I just chose to use Python to do that web scraping. All right, so back to the JSON world. To recap, we use requests to query this weather API. We have URL parameters that we could use, and requests makes it easy to get the JSON back. So no more demo stuff. Let's talk about a real application. So let me grab my notes. So at work, one of our products is a video therapy app, and some of the videos in this video therapy app are pre-recorded. The videos that we use are hosted by a vendor called Wistia. Wistia is kind of like YouTube or Vimeo, but highly focused on analytics. So they provide us with lots of information on who is watching what parts of the video and how much of a video. They also offer a web API that allows us to pull down those statistics and save them to our database. We then use that information to do things like send our patients reminders to watch videos, or we provide our patients with a report on how they did and what their treatment adherence was. And we use that data, we use the data pulled from Wistia to compute those reports. This is an example of a JSON object that we get out of Wistia. Don't be intimidated by this. Any good web API will have documentation that explains what this stuff is. So when you first start working with web APIs, don't let complex things like these keys that have a lot of random numbers in it to throw you off and intimidate you. So before we can start working with Wistia's API, we have to talk about something we have not talked about yet, and that is authorization. I would say this is probably one of the most common API scenarios people will come across. Authorization is important because in Wistia's case, they only want customers to be able to access their own data. And we don't want anyone to access our data, so it makes sense to use authorization to implement that control. Authorization usually is passed in the headers, and it's usually in the form of what is called an API token, which is just a really long string of random characters. And you get this token from the API owner. So to break down this authorization header, in a header, the word to the left of the colon describes the information that the header is representing. And then in authorization's case, to the right of it, there tend to be two words. One of them is the flavor of authorization. Most of the time you'll see bearer, but others you can see are basic and digest. And then the string to the right of the flavor is the string that identifies you. And the reason that this identifier is important is because it helps Wistia determine things like what data we can access, how often we can access it. Maybe we haven't paid for certain features, and the way they gatekeep some of those features is through API access. That being said, it's very important to keep API keys as secret as possible. These are, for those that are crypto enthusiasts, I would almost liken this to your private key. Like, it is very important that you do not share this. So what does it look like when we don't use authorization? So we import requests in this example. We have our URL, and then we send a request, and it gave us a 401. So going back to that meme, we fucked up. We did not send the correct authorization. To liken authorization to the document example we had before, it's like saying, hello, agency, please process and send me the document I need, and then putting a stamp on it. So if any of you watch Lord of the Rings or Game of Thrones, there tends to be a scene where a king will write something on an envelope, then drip wax on it, and then like put his ring into it as like his seal, his insignia. That's authorization. That's the king saying, I am attaching my authorization to this, and it is okay to respond to this with sensitive information. So let's make a request to the Wistia API. We import requests on line 1. On line 2, we have our URL. On line 3, we build a dictionary of the headers that we want to send. Just like the URL parameters, requests lets us create dictionaries of the headers, and then when we pass it to GET, it will appropriately add those to the HTTP request. This huge string that is the token over here is a real Wistia API token that I created and then deactivated for this example. As you can see, it's huge and it is highly random. Like, you know, it is very important that this string be random and be kept secret at all times. So we pass that into our headers. We make the same request that gave us a 401 earlier, and we get a 200 and we get our data back. But we have a problem. And that's if we make a request to another endpoint, we get a 401. And the reason for this is HTTP requests don't have any memory of past requests. They're all independent from one another. To help us work around this, requests offers us a session object. A session object is very similar to the session in your browser. So if you go to Facebook and you log in and you browse Facebook and you leave and you come back a couple hours later, it doesn't ask you to re-authenticate. It remembers that you logged in. And that's because your session is still active. So using the session object, we can look at the initial headers, and you'll see a bunch of different stuff that the stock session comes with. An important one to look at is this first one called user agent. User agent describes the client that is making the requests. In this case, our Python interpreter is readily announcing to the server that it is a Python script making the request. Because the headers are implemented as a dictionary, we can add our authorization to the headers, and then we can make our requests, and everything is all hunky-dory. Things work well. And using these tools, I would say one can work with most of the use cases that one sees when making HTTP requests in Python. Before the end of this talk, I would like to cover serving HTTP requests with Python, which means accepting requests and returning a response. So the Python language comes with lots of tools, and one of them is tooling to allow us to receive HTTP requests and return content back. In this code example right here, we'll just run through it real quick. On the first line, we're importing two things. We're importing a class that runs an HTTP server. And the second thing we're importing is what is a handler. And a handler is what should be done to each request that comes in. By default, in the default Python configuration, using the simple HTTP request handler, it'll look for an index.html in the directory that you're running this from, and it will return that. So if we ran this code snippet up here, and we had this HTML file in the directory at 127.0.0.1 port 9000, we would get the contents of this HTML file. So a talk would be incomplete without a live demo that has potential of failing. So I'm going to explain this code, and then we're going to run it, and you guys can interact with this HTTP server. We did slightly modify the HTTP request handler here, and the modification we made is kind of small. All we're doing is we're saying whenever a request comes in, so whenever you guys connect to this server, our terminal will print the user agent that your phone or browser is sending to the server. And this is a user agent that you are sending to every website you visit. So keep in mind that whatever we see on the screen, it'll probably say like Android or Mac OS or Windows. This is what your phone is sending to sites that it visits. So let's fire this up. All right. So I am launching this server here. This server is now running locally on my laptop at port 9000. So let's go here and just make sure it's working. Okay, cool. So that says HTTP and Python, and you can see that I visited it in Chrome, so it's showing some Chrome and Mac user agents. The next thing we're going to do is use a tool called ngrok. And what ngrok does is it takes a local server on your computer and exposes it to the internet. So this is really useful if you're working on something and you want to show a friend without deploying your server. You can use ngrok, and ngrok will put it on the internet for you. All right, so let's make this guy a little smaller. All right, give me one moment. This URL is really long and unruly, so I will create a QR code for us for those at home to use, and then you can just kind of take a picture on your phone. So we will use poetry and run a Python URL to that. Okay, and then we will open this PNG. Excellent. So I'll put this here. Let me close this guy. All right, so hopefully if folks use their phones and load up this QR code, try to spot your own user agent in the list. Oh, awesome, people are connected. Oh, it is deceptive. All right, cool. Awesome. So we can see that. So I have an Android phone, but I can see we have some iPhones connecting to it. We have, it looks like we have people using Mozilla, people using Safari, and this is a very standard example of Python's HTTP serving capabilities. It's important to keep in mind that the built-in Python server will probably almost never get used in production. You will probably never see it. You'll usually see third-party tools like Flask or Django, if you've heard of those. But in terms of just kind of learning, I recommend poking around with it. It's a fun little experience. And that is pretty much the end of the talk. So if anyone has any questions, I'm happy to answer a couple of them. Let me mute myself real quick.
Yeah. Well, round of applause. Yeah, that was a great talk. I loved it. I loved you using ngrok. I've used it myself for more nefarious reasons, but we won't get into that. Yeah, so I had a couple questions. If anybody online has questions, feel free to pop them in the chat or raise your hand, push the raise hand button, and we'll get to you. Oh, okay, cool. That sounds good. So, so if you were using a web app, or you made a web app online that you, I believe, were making requests to Wisteria or Wistia.
Yes.
What's your framework? And I guess it's two-part. It's kind of two questions. What's the web framework you use there, and what's your preferred web framework for Python?
Yeah, our preferred web framework is Django. We are a Django shop. Early in my career, I started out with Flask because it's simpler. But as time went on and our requirements grew, Django made a lot more sense. For those who are unfamiliar with the Python tooling, but still familiar with web technology, I think Flask is really, really great for microservices. So at one point in the future, we plan on adding some microservices, and those will probably be in Flask. But at the moment, we are a Django monolith app, and we're actually quite happy with it. Django is wonderful.
Agreed. Yeah, Django is a beast to learn when you're first getting started. Totally agree. I started on Flask myself, and then I ended up in Django. And actually, I work a lot in machine learning, and we've actually moved on from Flask. We're using Fast API a lot now. Yeah. Fast API is just amazing, an amazing accident that became huge. So we're loving Fast API right now. Which kind of brings me to another thing. So when you were making requests online using Beautiful Soup, does Beautiful Soup have built-in async functionality to do those loops that you were doing through the links? So as you're following links, right? As you're doing that, that's going to block, right? And you're not able to get through each link on a single thread. You'd have to use something like multiple threads or async calls, which can
Yes. Great question. Yeah. I'm unsure on Beautiful Soup, but in terms of making the network requests, the reason I picked requests was because it's very ubiquitous in the Python world. So, like, I feel anything you look up in terms of making HTTP requests in Python, you'll use requests. But actually, at work and both in my personal stuff, we use a library called HTTPX. And HTTPX supports async natively. In fact, I highly recommend everyone who uses requests to move to HTTPX because it has the same exact interface, so you don't have to change any of your code. You can just swap out the dependency.
Yeah, that's really nice. And this is something that I actually dug into recently when I was doing web scraping. If you're scraping and following hundreds and hundreds or thousands of links through the internet, the last thing multi-threading, right? Or, can be a bit cumbersome, we'll say, a bit complex. So they've actually integrated async capabilities into Python natively now, which is great. But if HTTPX handles that, that's also great. I was just curious how you would handle that in a more production setting rather than a demonstration. Obviously the for loop is easy there. So cool. Well, does anybody have any other questions? No? Good. Okay. Well, we will leave it there. Oh, wait, George, last minute question. Go ahead, George.
Hey, how's it going? Thanks for this demo. It was really good. Of course, I have my problem at work, which happens to be EDI, and I see something like that soup. I can't remember its name, and wondering if that could be used to parse EDI files. Any experience with that, or any knowledge about that?
Tell me more about EDI files. What is this? I haven't heard of it. So is it similar to JSON or XML?
Well, EDI is a standard for exchanging business documents electronically. So things like purchase orders and invoices, lots of those sort of business documents that big companies use. And so, like the company I work for, it has a contract with Fred Meyer, and Fred Meyer sends purchase orders via EDI, and then we send back an acknowledgement saying we got this thing, and eventually when we're shipping it out to them, we send them what's called an advanced shipping notice, and then eventually we send them an invoice. All this is done electronically, and they're structured documents, but they're not as neatly structured as, say, JSON or XML or something like that. And sometimes these documents are converted to XML for moving into, from the EDI processor, what they call a VAN, a value-added network, into your ERP system.
So I went back to one of the Beautiful Soup slides. So on the fourth line, you can see that we're passing in that HTML variable. What we
Right.
don't see is that there's a secondary variable that can be passed into the beautiful soup call that indicates a class that will be used for the parsing. So while I'm not sure whether Beautiful Soup supports EDI parsing out of the box, but if you enjoy like the structure of find all or dot find and that kind of syntax, you could most likely write your own EDI parser as a module to Beautiful Soup. Whether they'll accept it as part of the module, who knows? But you'll be free to use it on your own.
Great. Thank you.
Yeah, of course.
Great. Yeah, that was a great question.
Yeah, thank you.
And George is coming back. I think he has another question, follow up. Go ahead, George. Or maybe not.
No, that was a mistake. I was trying to
I thought it
bring my
might-
hand in.
Yeah. No problem. Well, any other questions that we can answer before we wrap up? All right. Well, we will leave it there. I want to thank Adam for his presentation. You're not local. Where are you located? Where are you from?
Right now, my wife and I live in Denver, so
Okay.
we will be heading back there at the start of October. We've been just checking out Portland, and
Cool.
we've loved the city, so we might be back.
All right. Well,
Yeah.
that'd be awesome to have you back.
Yeah.
And just in general, have you back for a talk. That was a really great talk. I think it was really informative. So
Thank you.
absolutely. Okay, everybody. Well, that is our talk for this evening. I appreciate everyone who came and all the thoughtful questions. And next time we're going to be hearing about Python package management using libraries package managers like Conda, Poetry, and so forth. So definitely check that out, and we'll see you next time. Thanks.